I'm telling you that it's here in 20C and I need you to control your excitement. Hello everybody, welcome once again to DBA Office Hours or Database Office Hours, or just Connor in Perth liking talking about the technology and in hoping that you enjoy it as well. It's another jam-packed hour of stuff to get through. Hopefully you'll find it entertaining and hopefully you'll enjoy what we have to talk about. As always, the chat line will be up. I'll do my best to try and remember the chat line and check it from time to time. But let's jump into the screen share and we'll get going. Okay, so hopefully you can hear me. Hopefully you can see the slides and hopefully you can see me as well. Therefore ticking hopefully all the boxes. As I say every month, I enjoy talking tech, not just on Office Hours. I like doing it on Twitter, on blogs, etc. So if you ever want to get in touch with me, go to linktree/Connor. It's got blog, Twitter, Facebook, Instagram, LinkedIn, etc. Whatever your social media flavor of choice is, you can get in touch with here. I will give one word of warning. This is a bit of footage. Hopefully it'll come across over my terrible network. This is a bit of footage I took a couple of hours ago before the sun went down. This is what the weather has been like in Perth for the last couple of days. It is absolutely cannoning down. We've had trees down, we've had hail and storms. So I'm sort of hoping that the power doesn't go out. We've had a few power outages over the last 24 hours. So if all of a sudden the Zoom session goes very quiet, it's not because I've lost interest, it's because the power has gone out. As I always say at the start of Office Hours, do not adjust your set. All the content appears down at the bottom left, such that we can turn this into a YouTube video later and put me at the top right. A few bits and pieces, and I want to try and get through such that we can get into the content. What I've been doing since the last time we spoke on Office Hours. I went to Italy. This was one of the very cool t-shirts that came out at the Italian conference. The Italy conferences in Milan and Rome. Shout out to Francesco, who did a fantastic job organizing them, and Roberto from Oracle Italy. Both those made those events very, very successful. Then I went to Israel. A regular on the Office Hours calls, Judith, generally shy about having selfies taken, but I cornered her in the room. And yeah, so we had a great time in Israel as well. Also, big shout out to Oren if he's on the call. Fantastic hospitality, fantastic host, and anyone who's in the Israel area, I'd recommend you go to that conference either as a speaker or an attendee. Really fantastic time there. From there, I went to Portugal. Portugal had a conference called S-Info or Sinfo. And it's actually, if you ever get a chance to go there as a IT professional, I'd recommend it because it's an event totally run by students. The whole thing is run by students, organized by students. They invite speakers from around the world, but it's more a showcase of the students being able to run a complete event. So it's live streamed, they record the sessions, they have chat rooms, workshops, etc. So yeah, so have a Google for Sinfo, a really cool event, and Lisbon was fantastic. Coming up in March, I've got the Romanian Oracle user group. So if you live in Romania, I hope to see you at the event in there. I've then got OUG Ireland. I'm doing an event at Qualogy in March, or hopefully I'm pronouncing that correctly. It's where anyone that knows Patrick, the ACE director, Patrick Beryl, he works at Qualogy. And then we've got Apex World in Rotterdam. All up, I've got 5 events in one single airline trip, which is going to go through Europe in March. And hopefully I won't pick up any nasty viruses on the way. Certainly I should have bought some shares and stocks in surgical mask companies from the last few flights I've had. It's just out of control. Gotta love that paranoia. You're flying too much actually when on the last flight I took on Emirates, turns out one of the stewards, one of the crew, was a girl I coached volleyball in high school in Perth. It didn't get me an upgrade, but still, when you start being on first name basis with the airline crew, you may be traveling a bit too much. But I love reaching out to the community. The final bit of bits and pieces is XE. This one's hot off the press. Express Edition is still at 18C. There will be a 20C XE, I'm told. But 18C XE just got better because, as Gerald tweeted out earlier this week, you can now just grab it directly from the Oracle website. You don't have to do the classic SSO, click the license agreements, sign away your life, etc., etc. you can just get it directly, which means if you're on a Linux repo, you can just do a yum install and off it goes. That's cool if you're building things like Docker images and the like. So XE just got better. It's just that much more accessible now to you. The other one is, unless you've been living under a rock, you can now get 20C. We promised you'd get releases every year, and we're going to spend a bit of time later on talking about yearly releases. But yeah, 20C preview release is now available. You can get it if you've got a cloud account, and hopefully you all have, because you can get one for free and you can get the trial accounts, etc. So Oracle 20C available in preview. We'll even do some 20C stuff later on today. So this session, what we're going to talk about is no logging, the Cap Theorem, and I'll explain why that's pertinent for this discussion. 18C, 19C, 20C, and all that rigmarole, and some of the panic that I've seen on Twitter over the last week now that 20C's come out. Blockchain, this is going to be a bit of a repeat of what I know Chris covered last night in his SQL office hours, mainly because I want to reinforce a particular caveat, because in 20C, it's brand new, people are going to leap into it, but we'll delay that discussion for later. And count distinct. I'm going to talk about a new invention, so to speak, of count distinct. Anyone that was at the Israel user group, they'll sort of know what's coming here, and I'll ask you not to jump ahead of the gun when we do it for the other attendees, but we'll have a bit of fun with count distinct at the end of the session as well. Let's jump right into it. No logging. This is the question that came in. I'm trying to do no logging operations. And yes, I am using direct mode, but I'm still creating redo. Why is this? And just in terms of a quick background, most of us are aware that you can always been for a long time being able to set a table as logging or no logging, the default being logging, obviously. And in times gone by, we used to call it recoverable and unrecoverable, which generally raised some alarm bells, but logging and no logging. And it's relatively well known that you only get the benefits of that no logging if you're doing direct mode operations, things like parallel DML, insert append mode, direct load insert in SQL Loader, those kind of operations. The thing that made this question a little bit more interesting than sort of the classic historical question of why isn't no logging ending up with no logging is that this person was saying, I am using direct mode, and yet I'm still getting the logging created. So let's have a little look at that. And we'll do it obviously with a demo because that's the best way to explain anything. Let me do a new share. And what did I call it? Did I call it no log? I hope so. Okay, hopefully you can all see that on screen. I'm going to start with a table called T1, and I'm going to create it no logging. I'll put it there in uppercase, nice and explicit so we can see it. It's got 10 rows just from DBA objects, just a small table that we've seeded with some data. And here is the claim about append mode possibly creating redo logs, even though it's a direct mode insert, and even though this table we just saw is created as no logging. I'm doing insert append into T1, select object name, etc. from DBA objects, and I'm just inserting 10 rows from object ID between 10 and 20. In fact, I inserted 9 rows. So just a small little insert append to keep it nice and efficient. And here's the interesting thing. We actually did create some redo. The table is no logging. We're doing insert append, but we did create some redo. And it's a small amount of redo and something that probably we wouldn't really worry about. But let's now look at a comparison to a table that is defined as logging for the exact same sequence of operations. So I'll create table T2 exactly in the same way as I created the table T1. It's seeded with an initial set of data for just a few set of rows from DBA objects. I'll turn on auto trace. I'll do the exact same insert, just plonking in 9 rows, this time without the append hint. So this table is logging, and it has not the append hint, so it's a conventional insert. So if anything, there should be at least more redo. And this one has, well, a bit of a very big surprise, absolutely 0 redo. Now, that in itself we return to, but let's talk about the contradiction first, in the sense that I'm doing a direct mode insert and I'm getting redo. I'm doing a conventional insert and I'm not getting redo. The key to this thing is that remember what insert append was originally designed to do. If you have large scale operations for which you are prepared to accept some of the compromises, namely you're going to lock the entire object, then insert append mode is a great way of getting data in en masse. It's really designed for large scale operations. So I'm going to repeat this demo now in a much more larger fashion. So I'm going to drop T1 and T2. I'm going to recreate them exactly as before. T1 is no logging, T2 is logging, but now the tables have been initially reseeded just as the previous demo. Rather than just insert a smattering of rows, let's use insert append for what it was actually designed to do. I'm going to insert all the rows from DBA objects. It's still not what you would call large scale, it's only 70,000 rows, but it's big enough. Now look at the stats. Yes, we've generated a little bit more redo, about 38 kilobytes. But I think we can be pretty confident that if I'm inserting 77,000 rows, well, a row can't be half a byte, obviously. So we are definitely creating far more than 34 megabytes worth of data into the table. So this gives us that confidence that no logging and append has actually achieved some benefit here. We're not actually creating redo for every single row that we're inserting. So what is that redo? The data we're inserting does not have to be logged. That's the benefit of no logging and insert append. But however, the metadata that surrounds that table does need to be logged. I'm creating extents. That table is growing. I'm putting information into the data dictionary about this table, what the extents are, etc. Those operations do need to be logged because you do need to be able to recover them in the event of an instance failure. So that information does create redo. It's the recursive SQLs. You can see at the top, we did 128 recursive calls in there. It's some of those operations, which will be actual DML on the data dictionary, that needs to be logged. Hence, there's always a little bit of redo log that's going to be created, even with a no logging insert append. Let's now compare that 70,000 row insert with the conventional insert on table T2, which was created as logging. So now, insert into T2, select all the rows from DBA objects, and we see that the actual true benefit of insert append, I'd gone from 34 kilobytes of redo from up to 4.5 megabytes. And now we can actually see the true benefit of insert append. We're actually getting a little bit of redo compared to a much larger amount of redo. Now, I'd like you to try to remember that 4 megabytes of difference between an insert append and a conventional insert for all the rows from DBA objects. Keep that 4.5 megabytes in mind. That's a representation of the difference in redo to insert the table data. I'm now going to take this benchmark and amp it up a little bit. I'm going to truncate my tables. I'm going to redo the same insert in a second, but first I'm going to add some indexes. Indexes are different from just doing blocks in a table because indexes must be created in the right order. The data is stored sequenced in a sense. So I've created indexes on these tables. The tables are empty. Let's now redo those two inserts, one with insert append and one without insert append. So this is the first point I want to make. Insert append is great for no logging for table data. It does have fun benefits for index loading as well, which we'll see in a second, but the index data must be logged. And you can see here that I've actually created 20 megabytes of redo, even though this table is no logging and I'm using insert append. Because the indexes have to be maintained, I actually will consume some redo, even though it's insert append. Now you might be thinking, well, I've lost all the benefit of insert append. I used up 20 megabytes there. Let's do the conventional insert on the table now, which is defined as logging with the inserts in place. And that's 34 megabytes of redo size, you can see there. Now here's the important thing. I went from 20 megabytes to 35. It's an extra 15 megabytes. This helps show us that even with indexes on, insert append is actually a better version of insert for large scale operations if you can afford the locking, even when there's inserts on. Remember back in our first demo, the difference between loading the table and with append and no append was about 4 megabytes. Here with the inserts, the difference is 35 megabytes to 20. It's a 15 megabyte differential. It's not just the 4 megabytes of the table, it's an extra 11 benefit as well. So even if you have indexes on, you will still get some performance benefits using insert append over conventional insert. But as you can see, the ideal, if your redo log system is a critical component and you want to minimize that, The ideal situations for insert append is make the indexes unusable or drop them, do your huge data loads, and then recreate the indexes. And if necessary, you can create the indexes in NOLOGGING as well. So hopefully that explains why we do get redo, just a small amount with insert append, possibly a large amount if we have indexes on the table. And also, you're still going to get benefits over conventional mode insert. Now, there's one thing I haven't explained yet. And let's go back to the very first demo. I've got my table here, T2. It's a logging table. I did some inserts. I inserted 9 rows into the table. And I did a commit. No redo. That's odd, isn't it? Like, you think that everything must contain redo. I've done a change. Even if it's just 9 rows, even if I wanted to roll it back, I must do some redo of some sort. How can I have no redo size? It's actually you could call it a bug or an oversight in showing the age of SQL+. The redo size stat in SQL+ is showing the redo bytes written to the redo logs. Way back in Oracle 10, we actually made some improvements to the redo log subsystem in the Oracle database. For small changes, and I won't define what small is, but basically for small little changes, we can do an optimization, what we call private redo. And what private redo says is, well, I'm doing an insert in this session. I'll put this small amount of redo just into a private buffer, not the log buffer, which is basically what's going to get written out to the read logs, just a private buffer for my session. Because this insert, no one needs to see yet. It's an insert. There's no concept of someone needs to roll that information back yet. So until I commit it, I don't need to actually do any flushing out to the redo logs. So because I put the redo size out statistic there before I committed, there's actually just the information in my private redo buffer, not the standard log buffer. Now, how do I know that's going on? It's not really made available to us in depth, but if you look at some of your session statistics that start with the word IMU, that's actually not related to undo, it's actually related to in-memory undo, which is a pairing component. In-memory undo and private redo are two sort of memory components that go hand in hand. We can see there on the screen that I had a little bit of undo allocated and I had an IMU commit. That was my one commit. I took information from my private redo area and then flushed that out to the redo logs, which is not picked up in my redo size statistic in SQL+. Let's go back to the slides. So hopefully that answers 2 questions for you. That append can create a tiny bit of redo, but it's still going to be a lot less than a conventional mode insert. Indexes have a part to play. So append works, but as I said, remember the intent of append, large scale data operations, and the fact that redo has evolved. The classic thing of I make a change, it goes in the log buffer and that gets flushed to redo is still true by and large, but the Oracle database gets smarter and smarter with each version, and we actually have these things called private redos. If you Google for private redo strands or IMU and in-memory undo, there's various blog posts and white papers out there about that, but obviously it's really an internal optimization that we don't do a lot of documentation on. Let's move on. Let's talk about the Cap Theorem. The Cap Theorem is actually more related to NoSQL, and a question came in to me saying, I'm studying a NoSQL course, and I want to, hand on heart, I didn't want to go, well, I'm a relational guy, stop talking to me. The reality is, NoSQL is still a data modeling activity, a data technology, and we should know about it, even as Oracle database practitioners. I'm studying a NoSQL course, and it refers to the limitations due to the Cap Theorem. What is that? And I thought this was an interesting topic to talk about because as DBAs, most of us nowadays have to deal with a mixture of technologies. We're dealing with things like relational databases, NoSQL databases, whether they be Oracle or other vendors, etc. We're dealing with multiple technologies now. With a relational database, historically, this is what you've done. You start off with a small system and a small database running on a server. And as your system becomes infinitely more successful because you chose the Oracle database, throws in the marketing slide, this is what you do. As it becomes more successful, you get a bigger database and a bigger server. Now, that server might be multiple servers, but it's ultimately a single database and a single shared disk infrastructure, things like rack. So logically speaking, it is just one database across a single, possibly logical node. With NoSQL databases, the metaphor is slightly different. You start off with, for example, just a few small servers. So even at day one, you actually have multiple servers in the mix. And as you get more successful, you actually simply add more and more servers into the mix. NoSQL architectures typically go to hundreds or thousands or tens of thousands of small commodity servers. And the challenge obviously that NoSQL vendors had when they were first building their technologies is presenting that as one logical database. But because inherent in NoSQL technology is this concept of lots and lots and lots of nodes, it really means your data has to be partitioned across them. Unlike a rack system which has the data shared amongst all nodes, NoSQL systems are basically inherently based on the data being separated across nodes. The data is partitioned or sharded. And that's where the Cap Theorem came in. Eric Brewer, when he was talking about this concept of systems distributed across multiple nodes, wrote a theory which is when designing distributed web services, there are three properties that are commonly desired: consistency, availability, and partition tolerance, and you cannot have all three. So let's explore that from the realm of what we mean by databases. Consistency means if you have a database running on multiple nodes, it needs to show all the data the same no matter what node you pick. That's consistent. Availability means if I kill off a node, the other nodes are quite happy to simply keep chugging along, there's no drama there. And partition tolerance means if you lose a node, it doesn't have any impact on the other nodes. And when I say lose a node, it also means if the nodes can't talk to each other. That's what we mean by, when Eric Brewer first put this together, it was about messaging between the nodes. So if you can't talk to the nodes, that doesn't impact your system as well. And his theorem was, you get to pick any two. You don't get all three. So I thought we'd do this as like a Venn diagram. So we have availability, partition tolerance, and consistency. And what I thought I'd use is the metaphor of a petrol station, but we can think in terms of a database in terms of this. So the first option we have is you can have partitions and consistency. So in terms of a metaphor, here's my server station. If I have partitions, that means I can have lots of server station. If I want every single petrol station to always show the same price, no matter where it is, which means consistency, I want partitioning and consistency. What that means is, I want every server station to show diesel being 108.9, what it means is if I can't get in touch with one of those server stations, they're not picking up the phone. What do I have to do? I have to turn all my server stations off. That's what's meant by partition and consistency. I have multiple nodes, multiple partitions, but I want them all to show the same petrol price, always. What that means is if I can't talk to one of them, I have to shut them all down. I can't have availability if I have partitioning and consistency, because I would then lose the consistency if I can't communicate to one of them. They might change the price on me. So partitioning and consistency means I can't have guaranteed availability. Then we have this option. This is effectively like your Oracle database. This is consistency and availability. What I do there is I have one server station and I absolutely do my darndest to make sure that nothing can interfere with its operation. So I make sure it's on a big highway so people can come in and come out. I make sure it's on multiple electrical feeds so I never lose the power. I make sure I have huge reserve tanks so I'll never run out of petrol. I do everything I can to make that one server station always available because I can't have more than one. The beauty of that is it's almost always available because I've done that effort. And that's what, for example, what rack is. Rack is having multiple servers act as one without any kind of data partitioning. The data is shared across all servers. It's an availability concept to maximize the availability, but also because there's one, I'm guaranteed to have consistency. The downside is I don't get to have partitions. I don't get to have the data separated across multiple nodes because I can't have partitions if I want to guarantee availability and consistency. And then we have this one, which is partitioning and availability. So I want to have multiple server stations and I want them always to be available. So if I'm going to do that, I sacrifice consistency. What it means is one server station might show diesel at 109.3, another server station might show diesel at 108.9. And the reason this might happen is I'm saying I might not be able to talk between them. So partition is, remember, is partition tolerance. If I can't communicate between these two, I can never really know if they're actually showing the same price. So I've got partition tolerance, I've got availability, but I've sacrificed consistency. And in these situations, what I'm hoping for is eventually the phone line will come back, or the network comes back, and I'll be able to bring them into alignment. And this is what we do with NoSQL systems oftenly. So they're the three options you're available. And according to Eric Brewer, sorry, let me take a step back. I want to give a real life example of partition and availability as well. A real life example of partition tolerance and availability is Twitter. Recently, I tweeted out that I was heading to Portugal. That was on my browser. I fire up my phone, and there's no evidence of that tweet. Eventually, it will appear. That's what we mean by an inconsistent system. But Twitter is much more concerned about being available all the time and being tolerant to partition failures or networking failures than it is to have the data being consistent across all nodes. It's hoping that eventually it'll all just sort itself out. That leaves us onto this third option, which is, can you have all three? And anyone that claims you can have all three is living in a magical place where fairies and pixies exist. But we'll talk about the theoretical concept of having all three available, even though Eric Brewer's theorem says it's impossible. So in the NoSQL world, as I said, we always have lots of nodes. So partitioning tolerance is a mandatory. You've got to have tolerance to partition failures because inherently in most NoSQL architectures, you've got hundreds or thousands of nodes and the data is partitioned across them. So you must choose. You have to lose one. You can choose availability, which is what most of them do, or you can choose consistency. Almost they all chose availability. And that moves us from what we call acid to base. And most of us, I'm sure, are familiar with the acid principle, which all relational databases that claim to be anything have, the atomicity, consistency, isolation, and duration. NoSQL systems are generally more concerned about base, which is really just a play on words to make it the opposite of acid, because really it's actually only three things. It's basically available, which means it's always going to be there. It's soft state, and soft state really means stuff happens in the background without your knowledge. And what that means is I might make a change to data on one node, and that's all I did as a user or as an application. But behind the scenes, that data will be passed across other nodes to become effectively consistent over time, which leads to the E, which is eventually consistent. So we have acid versus base. Acid generally being the relational database theory, base being the more typical thing in NoSQL. And that, funny enough, it's, for database dinosaurs like myself who've been brought up in the relational world, that concept of seeing inconsistent data and never being absolutely sure what you're seeing is correct, it sounds to me like horrific, but it actually can be really successful, even for things like financials, which most people think financial systems, it's got to be acid. Things like Twitter and stuff like that, they can afford to be not consistent. But for example, if you go to Amazon, and I'm making this up, or Walmart or any online retailer, what's more important to them is not that you do a sale. What's most important to them is that you do lots of sales, therefore you have customer loyalty. So if I go to Walmart or Amazon or eBay or someone and I want to buy a phone, in an inconsistent system, I could log on to a node and see that the inventory for phones is 1. So I go, fantastic, there's one phone left, I'm going to buy it. I add it to my shopping cart. Because these systems are eventually consistent, what might happen is in the background, actually the inventory was actually 0. That's a delayed update coming through to your node. So by the time I go to check out, the inventory is actually -1. There is no phone to give me. Now you might be thinking that's a disaster in terms of data corruption, but it's not. But for a big retailer, what's more important is that they keep you as a customer because you'll do more sales in future. So what do? They simply cancel your order and they'll give you credit. They'll do something. They'll throw you a bone, so to speak. They might say, yep, I'm sorry, your order couldn't be processed due to some sort of fault. Here's a $10 credit for your next purchase. Most of us go, that sucks. But guess what? We stay customers. So even for financial transactions, if you architect your applications knowing that there will be inconsistencies over time, these kind of models can actually still be really successful because your business goals are be accurate most of the time and be able to recover if you're inaccurate and still reward the person doing the transaction. Don't get me wrong, these systems can be unsuccessful as well. This is one of my favorite quotes in terms of inconsistent systems. When Facebook used to do messaging, they used their bespoke NoSQL database called Cassandra. And when they actually launched Messenger, I think it was, back in 2010, they said, you know, this eventual consistency with messaging just sucks. And so they actually did some changes and actually went to a more consistency-based model to do messaging. And so, as I said, you know, you choose the architecture that best suits you. But that's the Cap Theorem in its session. That's the Cap Theorem in a nutshell. As we move along to more recent times, we have these things called what we call tunable cap. As I said, you can't have all three, but one of the nice things that our own Oracle NoSQL product lets you do is actually twiddle the dials, so to speak, to choose how much consistency or how much availability. You can actually have some control over that. And you might think these are absolutes, but let me give you an example. Most NoSQL technologies have the principle of, as I do a write, I write it to at least 3 or more nodes. And that's also a knob you can choose, but we always write it to multiple nodes such that we have recoverability. We don't want to lose data. Data can be eventually consistent, but we don't want to lose it. That's generally a reputation killer. So in this example, I'm going to assume you always write to 3 nodes. So I'll do a write, but what I might do is write just to 1 node and immediately tell the application that I'm successful. That gives me blazingly fast writes. In the background, something else is going to spread those writes out to the other 2 nodes, or 2 of the other 1,000 nodes that are floating around. So I got blazingly fast writes. Then when I do reads, I might always read from the 3 nodes that it could possibly write to. What does that give me? It gives me incredibly quick writes. Reads become slow because I have to read from all 3 nodes to make sure I get the correct, i.e. the latest data. So I can choose, I can have a knob that says, okay, I want incredibly fast writes because that's all I do, and I read rarely, not that often, but that data's got to be correct. So I might choose to write once, immediately say it's done, and then read all 3. That's a knob I could tune in some of our products. I might say, a write is complete when I've guaranteed to write to at least 2 nodes. So my writes are a little bit slower now, but that improves my read performance because now read only has to go to 2 nodes of the 3. So now I'm getting correct reads still. My reads are slightly faster than they were before at the expense of writes being a little bit slower. Or if, for example, let's say I'm just taking in IoT sensor data, I might just choose to do this. Write to 1 and say the write is complete. Now those other 2 writes are going to happen at some stage in future. I don't care. I'm just going to throw a read against any of the nodes. So I might get the wrong data. I might get outdated data. But I get incredibly fast writes and incredibly fast reads at the expense of data accuracy. But a lot of the systems that fall under these cap banners have these tunable knobs where you can choose based on the data and the importance of it. You know, if I'm taking in telephone calls for billing, I probably want something very, very accurate. If I'm taking in sensors from, you know, my Fitbit, I'm happy to drop, you know, 10% of the data because it doesn't really matter. And when we get to modern cap systems, if you think about what's happening now in the world of networking, one of the big pushes in our Gen 2 cloud is the incredible robustness and speed of our networks. And I'm not putting this on a marketing slide here. You know, you see a lot of this information from the Amazons and Googles and Azures of the world. They're all putting a lot of focus on the speed and quality of their global networks, Oracle obviously included. If you never lose the network, well, maybe the Cap Theorem is starting to become a little bit out of date, because if you never ever lose the network, you're more into this kind of realm. And that's why we start seeing these databases now that run globally and yet still claim to be all the principles of ACID. And I think this is probably one of the future directions now. As networks get just ridiculously good, the Cap Theorem becomes that little bit obsolete. And that's a good thing for all of us. We'll end up having systems which are hugely scalable and yet still guarantee us the quality of data and availability. So that's pretty cool. So that is the Cap Theorem explained. Hopefully that helps. And if you're a DBA who's never touched NoSQL systems, hopefully that helps introduce you to the way NoSQL systems work as well. Quick drink. Let's talk about 18C, 19C, and 20C, because 20C has just come out. The reason I want to talk about all 3 is because the moment we announced the 20C preview release this week on Twitter and blogs.oracle.com, Twitter, Facebook, etc., was alight with paranoia of that, No, I haven't even got to 12 yet. I haven't got to 18 yet. No, now 20, etc. I want to talk about the annual release cycle. And I want to clear the air here. I don't want to spend this next 10 minutes on 20C features or the excitement around 20C. That's for another day. I like 20C. There's some cool stuff in there. We'll spend a bit of that 5 minutes at the end when we talk about blockchain. When we announce the latest release of the database, 20C, the activity on Twitter, the activity on social media, the activity in your user group communities, that's a tough word, the activity on your user group communities is not about the features, it's about the upgrade cycle. Because we're in the middle of this, what I call the time bomb period, where so many people are on 11.2, and they know they've got to move because support is being extinguished. They've got to move, they've got to upgrade. They were thinking, oh, maybe I'll go to 18. Oh, maybe I'll go to 19, because the project hadn't started by the time 2018 finished. Oh, okay, let's live in 19. Okay, we're just about ready to go to 19. Oh, no. 20C, and people get upset with us. Upgrading causes angst, causes panic. Stop freaking out about upgrades. That's the core message from this next few minutes on this video. I know we do 18C, we got 19C, 20C, and yes, there will be a 21C, and yes, there'll be a 22C. And people are fretting about this. They're going, are you serious? Do you know how hard it is to do an upgrade? Do you know how much testing we have to do? Do you know how hard it is to get management approval for budgets to do upgrades? And you're telling us to upgrade every single year. No, we're not. This is what I wanted to explain on this office hours session. This is a critical point I wanted to get across. Releasing versions of the database every year, guess what? It's not our idea. It's your idea. Now, let me explain. This is not me trying to absolve any responsibility. It's what I describe as your goals as Oracle customers. All Oracle customers generally have goals of what they want to do with their database. And I broadly categorize all customers into two types, or having two sets of needs. And I say this because I was an Oracle customer before. For 25 years, I was outside the Oracle company as an Oracle customer. I love the tech, and that's why I joined Oracle. But in all my working Oracle life, I could easily categorize the companies I work for as two customer needs. The first one, the WTH, or maybe you could choose a slightly more profane algorithm, the WTH customer. And the WTH is what the hell is going on with all these versions? And it's probably best described as, look, I have a database. It's running sweet. It's 11.2, or it could be 10.2. It's 11.2.04. That's our latest supported version. I don't need upgrades. I'm not using latest and greatest features. I just love the fact that it's a rock solid database. All that matters to me is that the thing keeps running and you give me security patches, because the only thing that's going to break me is if I get hacked. And security patches are everything. So what's all this annual release stuff? You're killing me. But no, we're not. We want to satisfy this customer need. The first type of customer need is don't make me upgrade. And when we look at the critical slide, which comes from Mosnote 74200601, and I refer to people, keep going back and look for that. If we hone in, that's exactly what we're doing. We have 11.2.04, which you can stay on. You could stay on for a decade. That's like Windows XP. A decade you could stay on 11.2.04 and still be patched, still get security patches. What we're telling people now is 10 years is enough. You need to make the jump. We need to be able to keep you secure with a more modern version of the database. And that jump is 19C. That is the version that will be the next 11G, so to speak. It'll be the next 11.2.04. It's going to be the one that's going to be extended in terms of long-term support. And in fact, we have currently in that MetaLink note, we have support heading out to 2026, a 2019 release. That's 7 years, right? And I would imagine, and please don't quote me on this, you look at the 11.2 experience, 7 years was what we had 11.2, and then we eked it out a little bit more as people had those needs. So we start with 7 years, it might even be more. I don't know, I don't make those decisions, but 7 years is a long time of support for a product. So if you're a WTH customer, I want to stay with minimal upgrades, but keep me rock solid and secure, we have a proposal for you that suits exactly that need, 11 to 19. And in fact, that's why every single version of Oracle database you are currently on, you can go directly to 19. You don't have to do any hops. We've architected it such that you can make that one big hop when you're ready to 19 and stay there. And in fact, one of the cool things is the auto upgrade, and Mike Dietrich has a great blog post on that, is designed to make that as painless as possible as well. Don't get me wrong. I know, I've been an Oracle customer. You have to test. You have to do regression testing. Sometimes you have to make changes to your apps because of changes in the way things like the optimizer and stuff works. But there are tools in place to make that upgrade as pain-free as possible, and you can do it as infrequently as possible if you are a WTH style of customer. But that's not everyone. If you are one of these customers, you often have that blinkered view of that's everyone wants to be like that, minimal upgrades. But that's not the case. We also have what I call the OMG customers, the oh my goodness customers. And that is, for them, they were getting frustrated with us because we weren't upgrading frequently enough. The exact opposite. They were saying, look, there's a feature I need, it's got to come out, and you're telling me to wait 3 years. So for some customers, a certain feature could be the make or break for their business. It might be the competitive edge that's really going to give them a huge boost. And so for them, we have these annual releases. They're not every single one going to be the long-term support. They are maybe based at features. So you can see we have an 18, a 19, a 20, a 21, a 22, etc. Certain versions will be the long-term support releases for the WTH customers, and we will have these annual release cycles so we can rapidly get you new features that you're asking for if you're an OMG customer. We want to satisfy both customer needs. That's why I say this was your idea and your desire, and we're doing our best to meet that need. So I hope that alleviates some of that paranoia. And the funny thing is, even within a single customer, you can do this at the database level. And here's a real life example. The last customer I worked with before I joined Oracle did exactly this. They were 11.2 customer for their data warehouse. They went to 12.1 solely for a single feature, pattern matching. This customer had financial data. They were looking for fraud and compliance and audit style of activities. Pattern matching, perfect SQL fit. So pattern matching, 12.1, that justified the upgrade. They jumped to that, even though they were totally happy with 11.204. Then we went from 12.1 to 12.2. Why? Online table move. Because we could use the attribute clustering I've spoke about in an office hours before with online table move to cluster their data to make their data warehouse queries fly along. They weren't an in-memory customer, so clustering data was a huge bonus for them. Justified the upgrade straight away. So that was 12.2, and I missed one other thing, right? The 12.102 was so they could actually go to, what was it again? I can't remember. But yeah, they actually went 12.1, 12.102, 12.2, every intermittent release for certain killer features that made their data warehouse really important. Exact same customer, different database, totally different process. 11.204, they jumped to 12.2. Oops, don't hit the keyboard corner. 11.204, didn't go to 12.1, didn't go to 12.102. Maybe you can hear that huge thunder rumbling there. Went to 12.2, and they're going to go to 19. They're not going to go to 18 because that database was more about keeping the basic tech they were using, no killer new features needed, just looking at upgrades for security reasons. So within a single customer, you can choose to be aggressive or passive. You have that choice, and we are hopefully serving both those needs. Okay, what do we got? 9:45. I gotta stop talking too much. Blockchain. I didn't want to do too many things on 20C features because I've just said, we have customers that aren't interested in 20C just yet, and 19C is the long-term support. But there's one feature I want to talk about, blockchain, because I want to reiterate something that Chris spoke about on his office hours. But here's a warning on blockchain, even though it's a pretty cool feature. I'm telling you that it's here in 20C, and I need you to control your excitement. Let's do a bit of background first about what blockchain is, because most people, when you talk about blockchain, you know what they think about? How am I going to make money off Bitcoin? They're looking at the share price for Bitcoin. That's how they make money. Blockchain is not Bitcoin. Bitcoin isn't a application, for lack of a better term, that takes advantage of the blockchain technology. This is a very simplified explanation, but basically a way of understanding how the blockchain architecture works and how we've therefore implemented such a thing in Oracle 20C. You start off with some sort of financial transaction. In fact, I should say any transaction, anything which involves data. I'm using finances here. My bank balance is $0. That's generally not too far from the truth. My salary comes in at $200. That's a transaction. What I don't want is the bank jumping in there and saying, actually, we think it was $180. I don't want them tinkering with it. So what I'm going to do is I'm going to hash that information. That transaction has a hash. I'll apply a hash function to the entire block, and that comes up with a new hash that actually belongs on the block. Now, my next transaction comes in. This will be, I'm going to buy food so I don't starve to death. So the balance is 200. I spend $50 on food. I'll hash that transaction. I'll combine that with the hash of the previous transaction block, combine those two things to come up with a brand new hash for that block. And I can link the two together. You can see the little arrow. I have the commencement of a chain of blocks. And then the next transaction might be spending my $30 a month on my phone bill. So my balance for 150, it'll drop to 120. I hash that transaction, hash the previous block to come up with a new hash, and so forth and so forth. I have this chain of blocks, hence blockchain, of information where the hash functions link one block to the next or one block to the previous. Why is this really, really good in terms of security? Is because what if someone wants to come along and tamper with this? They want to tamper with, say, my food transaction. They say, actually, no, we want to manipulate that. We want to actually diddle the number and say you actually spent $80 on food. The supermarket is trying to have one over on me. To do that, they would have to regenerate the hash for that transaction, but also regenerate the hash for that block, which implicitly means they have to regenerate the hash for every subsequent block. And the hashing function is expensive to do. And that's the premise behind blockchain. The cost of tampering is prohibitive. You simply could not tamper anything in the blockchain without having to reevaluate all the other hashes as well. That's expensive or virtually impossible. Therefore, the information is tamper-proof. Vast simplification of the actual tech that's going on and the algorithms, but hopefully you get the idea. If you have sufficient hashes on all the information and those hashes are expensive and complicated to maintain or create, then you have tamper-proof data. That's super cool, but how could you do it in a database? Because databases have tables. You can do updates, inserts, deletes. They are designed to be tampered with. So let's do a quick demo. So this is a Oracle 20 database. Now, to set the scene here, I'm going to create a brand new pluggable database first. I'm going to do our demos in there. And we'll see the importance of that if you're going to start playing with 20C, that you maybe adopt this process as well. So a brand new pluggable called DB20 PDB2. I'm going to create a user called demo in there, give it the normal stuff, some quota, some resource, just privileges enough to create a table. And I create this new thing in 20C called a blockchain table. It just looks like the normal information you put on a table. There are a whole stack of hidden columns on there as well. That's for another office hours talk. This is about controlling your excitement with blockchain tables, not in terms of the functionality expose. So I've created the table. There's nothing in it, which means I can drop it. Sweet. But of course, that's not much use to me as a blockchain table. So I'm going to recreate it again and put a row in because I'm excited by this new technology. That's cool. I've finished playing. I've had a little explore. That's cool. I tried drop it. I'll connect to sys because after all, sys is God. Sys cannot drop that table. Nothing can drop a blockchain table until its expiry date is reached. I should have mentioned that. The example I hear was actually 16 days. That table is there for 16 days. Maybe if I drop the entire user. Nope. You cannot even drop the user. That table is there, that user is there for the next 16 days, period. That's what I wanted to explain and warn you about. If you jump in and start playing with these things on 20C, your preview release, be aware that blockchain tables currently are there not to be tampered with. The whole concept of blockchain is you can't tamper, including drop. Now, it's an interesting scenario here. Like, what are we going to do, like, in terms of, well, what if I've got things like unit testing or integration testing, or I've got those kind of continuous delivery things? That's something I think that internally at Oracle we may have to tackle. We might have to come up with, for lack of a better term, fake blockchain tables or temporary blockchain tables, something that lets you, not treat it as a real blockchain table. But out of the box in 20.1, that's what it is. It is a genuine, robust, cannot be tampered with, foolproof blockchain table. The only way you can get rid of a blockchain table at the moment is the same reason I created a brand new pluggable for it. You have to drop the entire pluggable database to get rid of a schema which contains a blockchain table. So that's the warning I wanted to give to you. That's all I want to talk about in terms of blockchain tonight, is that you need to be aware that you cannot drop them in any way, shape, or form without blowing away your entire database in this iteration of 20C. Hopefully that's enough of a warning for us all. As I said, be careful or be sure. Don't get me wrong, if you want to run these things in production, they're rock solid, because you will not be able to tamper with them, and you're going to have quality blockchain, non-tamperable data in there in your relational database. You don't have to go buy a brand new product, etc. And you get all the benefits that come along with the Oracle database as well. 9:52, count distinct. Can we get this under 8 minutes? I hope so. Count distinct. This is the question that came in. Why is count distinct such a problem in SQL? It makes everything so slow. And this is true, but I want to stress here that distinct is hard. And if I gave you the yellow pages this weekend, for those young people on the call, the yellow pages is this device we used to use to look up phone numbers. But if I gave you the yellow pages and said, how many distinct suburbs are there in there? That's hard work. It's much harder than if I said how many pages are in there, or how many rows are in the yellow pages. You just simply count them. The distinct number of anything in a large data set is hard to do. But I had an idea for a brand new invention. Now, anyone from the Israel user group, I don't want you to jump in here and say that I'm lying, because I am, but I have a brand new invention here to improve the way we do count distinct. And let's run through this last demo. Hopefully we'll get it done in time. Here's my employee table, the stock standard employee table, and I can obviously run a select count distinct department number, and there are 3 distinct department numbers. So let's be Oracle developers, not developers of with Oracle software, developers of the Oracle software. Let's build how we would do distinct. So my first crack at doing a count distinct would be, well, I could sort the data. So I could effectively have them in department number order first. And then all I do is, as I'm going through the data, is I pluck off every time the department number changes. Now I can do that in code, or I can do it just with an analytic function. I'll just use a lag function. And I can see that the first department 10 gets a 1, department 20 gets a 1, department 30 gets a 1 in that column called new val. And so if I want to do count distinct, I just have to count the new vals, and I get 3 distincts. Now, this isn't my invention, obviously. Oracle database can do exactly this. And in fact, if we actually just do a explain plan on select count distinct department number from employee, guess what? Sort the data in a group by fashion like we just did, and then work your way down and do the count. So our homegrown solution there is exactly what the old database kernel does as well. Can we do better? Because let's face it, the thing that sort of seems to be lost over here is the fact that I just did a big sort. It's fine to sort 14 rows on the employee table. What if I want to sort 1,000,000 rows? Sorting is really expensive. So I came up with this brainwave. How about, rather than sorting, I create a hash array. So I'll simply loop through every row in the employee table, and I'll use this column of interest, the department number, as being an index into an array. So every time I hit department 10, I'm simply doing hash bucket 10 equals yes. And I'll do hash bucket 20 and hash bucket 30 equals y for those 3 department numbers, but it's a nice sparse array. And at the end of it, I simply have the number of entries in that hash bucket array is my distinct count. So if I wrote it from first principles, distinct equals 3, I get the right result. And that works sweet as well. And I'm super impressed with myself for the fact that I've invented this brand new technology until I actually run select count distinct again on Oracle with a more modern version. And guess what? That's exactly what we do. we simply do a hash group by as opposed to a sort group by. So someone in Oracle had this brainwave many, many years before I did. And in fact, the reason it's hash group by is when we do count distinct in Oracle, what we do is we actually can rewrite the query like this. We can say select department number from group by department number. That's effectively like distinct department, and then do a count of the result. That's why we actually says hash group by, because under the covers we've rewritten a distinct to look like a group by. And we can actually see hash group by on this view, followed by a count, aggregate the sort. Let's look at a slightly bigger example now. Rather than just the employee table, I'm looking at DBA objects, which has lots and lots of rows, but just for the 4 owners. Because those examples so far were just count distincts with no partitioning of data. What if I want to do a group by owner? So I want a count distinctive object ID now for each different owner. Well, we actually still have this nice optimization. We have a hash group by inside of view, and then a second hash group by. All the distincts have been removed. They've been converted to group bys so we can use this hashing function. What's going on behind the scenes is we're actually rewriting the query like this. I need owner and distinct object IDs within owner, so I can do a first group by both of them. That gives me about 50,000 rows. And then I do a count or object ID based on the owner. So that gives me the distinct object IDs, the inner query, and then I do a group by to get it by owner. And you can see I get hash group by for the object IDs, hash group by for each of the owners, and the result comes out as one would expect. So this is pretty cool, but obviously my great hashing bucket invention has been shot to pieces. But what if I have 2 sets of distincts? This one's owner, I want distinct object ID, but I also want count distinct of another column. Well, that's going to make a mess of my group by here, and it does. Once I have more than one count distinct, I have to fall back to the sorting operation. That's what we have to do. And in fact, even if I don't have owner in there, even if it's just a straight count distinct across the entire table, the moment I have 2 of them, I'm apt to sort group by. So I have this issue. That's a bit of a problem. So maybe here, the great Connor McDonald invention, maybe here's my chance to build something new inside the Oracle kernel. So I thought, can I fix this without using a big sort? So to do it, I'm going to start with a nice small example. I've got a table called T1. It's only got 30 rows and just some random values between 1 and 60 for 2 columns. And I'll run some queries. It's got 30 rows in it. There are 23 distinct values for Q1 and 22 distinct values for Q2, just using DBMS random. I want to be able to get that without doing a sort. So here's my theory. I can build up hash arrays for each different column. So here's my values from 0 up to 60. I've marked them out from 0 to 10. And so the first row is 14 for Q1 and 13 for Q2. So I'll simply put them in my little hash bucket in position 14 and 13. This will just be a string. And then when I get 28 and 57 for the second row, I'll put them into my string as well. And so on as I keep building rows. I'll read each row from the table and simply plug the holes in these little hash arrays for each of these. That's my theory here. I can extend my hash bucket to be multiple columns. So this is what I've done. I've done it with strings rather than arrays, just to keep my logic nice and simple. I have these arrays that go out to 64. They're my numbers 1 to 60 inside my table here. So for each row in T1, if I get a value of 14, I'll simply put a 1 in position 14 and leave the zeros in position 13. Position 1 becomes a 14 and the rest becomes 0 still. I do that for column Q1, I do it for column Q2, and at the end of it, my hash bucket should reflect the distinct values. So I spit out some output and you can see this is what I built. There was a value of 1, position 1 in column Q1. There was a value of 3, a value of 4, a value of 6, and so on. And same for Q2. And then all I've done is simply counted all the 1s inside each of these values. And I got the right answer. There were 23 distinct values for Q1 and 22 for Q2. That's pretty cool. I've built a count distinct using hashing with no sorting. Of course, my solution only scales to numbers up to 64. The moment I get a number over 64, I'm in big trouble. And obviously I could make my strings, up to 32K? But then I get a number at 10, at 100,000, I'm going to break here. So I need to do something a little bit more complicated to prove that. I know I've just popped over 10 o'clock, I'm nearly done. So I'm going to choose some bigger random numbers now. You can see that I got numbers up to 17,000 and 28,000. Can I solve this problem still limiting myself to a hash bucket size of only 64 bytes? Well, I can, but I need to have multiple hash buckets. So now I have an array of hash buckets. And so what I do now is this becomes a lot of a bigger set of code. And what I'm doing now is I'm just doing this for column Q1. Bucket number 4 is all the numbers from 4 times 64 to 5 times 64. Bucket number 14 is all the rows from bucket 14 times 64 to 15. So this will be, let's say that's 20 long. That's the value of 200, for example. This will be the value of, 904. I'm making this up. But we have lots of different buckets. Now we need to add up all the bits in all of the buckets to come up with a number distinct of 37, which is actually the correct answer. And I could actually write more code to make it for Q1 and Q2. But I'm very, very impressed with myself here. I've written a hash bucket function that scales well, no sorting, and I get the right answer. I'm very, very impressed with myself until I realized that in 19C, someone invented this anyway. And these are some new functions in 19C that you can use. And they literally do exactly what I've sort of just explained there from first principles. I need a bucket number to manage large numbers, and I want to construct a list of bits for distinct values in a particular column. And it gives me roughly what we saw before in our strings. Bucket number 1 has this now sort of bit operation. It's actually a blob. And so if I want to effectively work out the distinct values, I take my buckets, I take my bit strings, I replace all the bit strings with 1s to count them up, and I'm done. So the same logic we did with strings is now available natively with bits in 19C, and I get the right answer. So at the moment, you can write your own functions like this. You get count distinct with no sorting, and you're using these new functions in 19C. If I need it for both Q1 and Q2, I get the bucket for Q1 and Q2, I construct this bitmap for Q1 and Q2, and then I roll up and count the bits just like we did with our strings, and we get 37 and 34, which is the right answer. As we can see, actually I haven't got an idea. It's all been invented already and implemented now in 19C. And one of the cool things is these new functions in 19C are specifically designed for materialized view rewrite. If you have materialized views that use those new bitmap functions, those bit counting functions, someone can write a standard count distinct query, and we will automatically rewrite to use your materialized view to get the benefit of these new bitmap operations, which no longer need to do massive sorts. So count distinct is a problem that is coming closer to being solved with 19C. We are done. Thank you for your patience. I know I ran 4 minutes over time, but hopefully got some value out of all of that. And yeah, please reach out to me. And if you have any questions about the blockchain stuff or the bitmap stuff, I'm happy to, when I do the videos, I'll expand them out a bit longer as well. And I can send you the YouTube links as well. So thank you very much for your time. Hope you enjoyed this office hours session. And we will see you in a month's time. If not, in OUG Ireland, or Apex World in Rotterdam, or in Romania, or in Qualogy in Netherlands. If you're anywhere in Europe, please come say hello. I love talking tech, and it's much better than doing it than over a webcam. But thank you for coming along, and we'll see you all next month. Bye for now.